In this video, we're going to cover how to sketch a graph given a slope and a point. The fast option is to use the point to start counting your rise and your run. There is an alternative format, but this is more complicated, but sometimes a point falls outside the graph paper and you have to use the y equals mx plus b formula or slope-intercept form by substituting the x and y points and slope to determine the y-intercept. You start graphing your slope from the y-intercept instead of the given point. This helps you sometimes when your graph paper is not big enough. There's also another trick that can be very helpful, and that is a positive slope counted up and to the right is equal to a slope counted down and to the left. Let me give you an example of that. So if your slope is equal to -5/2, then this is equal, when you're counting rise and run, to +5/2. Now let's take a look at the first example. Graph the line that goes through -3, -4 with a slope of -3/2. First, let's find the point that the line goes through. We're going to count to the left from the origin 1, 2, 3, and then we're going to count down 1, 2, 3, 4. Now remember, this is because the x and the y values are given, and x is your horizontal movement and your y is your vertical movement. So the coordinate point that the line goes through is right here in the third quadrant. Now I need to find the slope. Well, m is equal to, and just like I showed you in the initial portion of this video, -3/2 is equal to 3/2 if we're counting slope. So from this point, we need to determine our rise and run. If I look at the -3, that's our rise, so we're going down, not up, and our run is +2, so we're going to the right, not the left. Let's go ahead and calculate that. If I go from the coordinate point down 1, 2, 3, and then to the right 1, 2, that's great and all, but it's off the graph. And so that's not as helpful as if we counted up 3 and to the left 2, which in slope counting is equivalent. So we're going to count up 1, 2, 3, and to the left 1, 2, and that is on the graph. And notice that if I make a line, I can get it to go through all of these points, and I'm guessing here for the part that went off the line, but notice that a rise that's negative and a run that's positive is equivalent to a rise that's positive and a run that's negative. Okay, that sounds confusing, so let's try this again. In example 2, we need to graph the line that goes through 5, 7 with a slope of 2/5. Now in this case, 5, 7 is like right on the edge. So over to the right 5, because this is x and it's going to the right, y is 7 and it's up. So over 1, 2, 3, 4, 5, up 1, 2, 3, 4, 5, 6, 7. So can you see that we have a point here, 5, 7, that is not on the graph? So that's not helpful. So at this point we need to use slope-intercept form. We need to find b. This is my y-intercept. So I know the two values for x and y. So y is 7 and x is 5. And now I'm going to substitute my other values in. My slope, m, is given as 2/5. And I need to isolate b. b is my y-intercept. That's what I need to find. So 7 is equal to, now remember 5 is a whole number, I can put it over 1, 10 over 5 plus b. Multiplying straight across gives me that 10 over 5, and I can reduce that. 7 equals 2 plus b. Now, what plus 2 gives me 7? That means I need a 5, I think. Let's subtract 2 from both sides. b equals 5. So my y-intercept is at 5. So now I have another point. 0 in the x direction, 5 in the y direction. Now I have to look at this 2/5. Remember that up and to the right, rise over run, is equivalent to down and to the left. So if I count up and to the right, I can also count down and to the left the same amount. So I can say -2 over -5 is equivalent. So I'm going to count from the y-intercept down 2 and to the left 5. And that's my next point. Now I'm going to connect the dots. And there's the line. And you can see that right here I was guessing, and so it's not really nice, really accurate, but it's close, and it's a good just check to make sure you're kind of on the right track.